Hey guys, I'm going to run through the 7.2 homework. Alright, so tell whether the sequence is arithmetic and explain. So an arithmetic sequence, so here we have a sequence of numbers 1 to -1 to -3 to -5 to -7. So if it's arithmetic, then the pattern has to be increasing or decreasing by the same number. So from 1 to -1, what sort of a change is that? That's a decrease by 2. -1 to -3, also a decrease by -2, -2, -2. So because every term decreases by the same amount, that pattern is called arithmetic. And so yes, we refer to that as the common difference. So the common difference is -2. For the next one, we go 5 to 8. That's a change by 3. We go from 8 to 13. That's a change by 5. So already you can tell that there isn't the same change from one term to the next, so one pair of terms to the next pair. And so no, this is not arithmetic. For 3, 4, and 5, write a rule for the nth term of the sequence. So the general rule, how do you write a rule for the nth term of an arithmetic sequence? The rule is a sub n is equal to the common difference times by n minus 1 plus a sub 1. The common difference is what we've talked about before. It's the pattern in the sequence, and a sub 1 is the first term. So first of all, I'm just going to find the pattern. So 12 to 20, that's an increase by 8. 20 to 28, increase by 8. 28 to 36, increase by 8. So when I write the rule, a sub n is going to be equal to 8 times by n minus 1 plus the first term, which is 12. And there you go, you have the rule. And this rule can be used to help you find any other term in the sequence. So this is the first term. This is the second, third, fourth. If I want to find the 10th term, well, then I would replace n with 10, because n just refers to which number term. So if I want to find the 10th term, a sub 10, I plug in 10, and I evaluate the expression to get whatever the 10th term is. Okay. Next, so just again trying to find the pattern, 51 to 48. That's going to be a decrease. So that's going to be a decrease by that's going to be 3, I think, right? And then a decrease by 3, decrease by 3. So that means the common difference is -3 times by n minus 1 plus the first term, which is 51. And there you go. Oh, whoops. We should be using this rule. It's asking us to find the 20th term. So a sub 20 is going to be equal to 8 times by 19 plus 12. I'm going to pull up a calculator. So 8 times by 19. And then plus 12. So I've got that the 20th term is going to be equal to 164. And then a sub 20 here, that's going to be -3 times by 19 plus 51. All right, so -3 times by 19. And then plus 51, and I've got that the 20th term is equal to -6. All right, so here, what's the difference? So from -1 to -1/3, that's an increase by 2/3. -1/3 to +1/3 is also an increase by 2/3. And 1/3 to 1 is an increase by 2/3. So a sub n is going to be equal to 2/3 n minus 1 minus 1. And a sub 20 is going to be equal to 2/3 times by 19 minus 1. So let's see. All right, 2/3. And then we have times by 19. And then we're going to subtract 1. And I have that the 20th term is equal to 11.667. That's the same thing as 11 and 2/3. And that's going to be equal to 35/3, I think. Yeah, 35/3. That's fine too, though. All right, write a rule for the nth term of the sequence and graph the first 6 terms. So now notice here that we don't have the sequence given. We're given the 11th term in this case. The 11th term is 43. The common difference is 5. So if you imagine the sequence a sub 1, a sub 2, a sub 3, dot, 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 all the way to the 11th term, a sub 11. The 11th term is 43. The common difference is 5. And so when I write the rule for the nth term, we have a sub n is equal to 5 times by n minus 1. However, I still need the first term. So how do I go from 43? Well, you would have to subtract 5, subtract 5, subtract 5, subtract 5, subtract 5, subtract 5 in order to get to this first term right here. You would have to do it 10 times because this is the 11th term. And so if you take 5, 1 second, well, I don't, 5 times by 10 is going to be 50. So that means what separates, so again, if I go back 5, I have to go 10 times in order to get to the first term. So we do -5 times by 10, which is going to be -50. So I can take 43 and subtract 50. So that would mean that my first term would have to be -7. If you want to verify that this is the correct rule, so you can plug in 11. So plug in for the 11th term. So just to kind of verify, you do 5 times by, well, if you plug in 11, that's going to become 10. 10 minus 7, that's 50 minus 7, which is 43. So the rule does work for that. And then you're going to graph these terms. And so the first term we said was -7. That'd be right there. And the common difference is 5. And so -7 plus 5 is going to give you -2. So for the second term, it's going to be -2. And then again, you're going to go up 5. So for the third term, you're going to go from -2 plus 5, and so that's going to be 3. And then you're going to go up 5 again from there, and that's going to give you 8. And then for the fifth term, 8 plus 5 is 13. And then 13 plus 5 is going to be 18, so right there. And there you go. You should have the first 6 terms all right there. Alright, so here we have the 20th term. So a sub 1 all the way to a sub 20, which would be -27 for the 20th term. The common difference is -2, so meaning I would subtract -2, subtract -2. I would have to subtract -2 26 times to get here. So I would have to add 26 times by 2 in order to get to the first term. And so -27, well, again, the common difference is -2, and then we would have to multiply that by 26 terms. So 2 times by 26 should be 52, I think. Yeah, 52. So that means that there's a space of 52. So again, you got to get the sign right, though. So because the common difference is -2, we have to do -2, -2, -2, but in that case, starting from -27, I would have to add 2 to go back I have to add 2 each time to go backwards. So negative 27 plus 52. Whoops. So 52, 27, and that's going to be 25. This would have to be 25. And so our rule a sub n is going to be equal to negative 2 times by n minus 1 minus 27. Just to verify, to make sure that I have this correct, I'm going to plug in 20 in here. So that would make this 19. So negative 2 times by 19. Oh no, this isn't looking good for me. Minus 27. Did I do it the wrong way? I think I might have. Oh, what am I doing? That's not minus 27. That's plus 25. Sorry, I put the wrong, I didn't put the right one. So that makes a lot more sense. So negative 2 times by 19. And then we're going to add 25. Uh-oh, I'm still not getting the right thing. What am I doing wrong? So I'm checking to see if my rule is right, and right now it's definitely not. Let me verify. So 25. Clear. So 25 minus 52. So a sub n is going to be equal to negative 2 times by n minus 1 plus 25. And if I want to find the 20th term, I'll put that in here. So negative, because right now it seems like it's working. So negative 2. You guys can probably see what I'm doing wrong, and then you're just like rolling your eyes at me. Times by 19 plus 25. The 20th term is negative 27. And the common difference is negative 2. For some reason, my logic is not matching up with my equation. Common difference is negative 2. So if I take 25 and I subtract 2 times by 19, yeah, that is not working out right there, actually. What am I doing wrong, though? All right, so kind of just going backtracking. So a1, and then if I subtract negative 2, subtract negative 2, subtract 2, subtract 2. If I do that enough, I'm going to get to negative 27. So if I backtrack, that's going to be adding 2. So negative 27. And then if I add 2 19 times, negative 27 plus 2 times by 19. Wow, I just redid that, and for some reason I was doing 26 from 27. I don't know why I chose to do that part. I don't know why I chose this right here. It's not 26. That was supposed to be 19. I think I was looking right here, but it's the 20th term. So that was the wrong part right there. Oh, man. There we go, because that makes a lot more sense now. And then I get 11 as my first term. There we go. I get 11. All right, thanks for sticking with me there. So if I do a sub n is equal to negative 2 times by n minus 1 plus 11. All right, let's try it this time. So if I do negative 2, and then if I plug in 20 right there, that's going to be times by 19. And then plus 11, I get negative 27. Okay, there we go. Found my mistake. For some reason, I did 26 terms because I was looking at this, but it's the 20th term. Okay, all right, I found my the right rule. And then we know that the first term is 11. So the first term is 11. And then it's going to be subtracting 2 each time. So it's going to be 9. Then it's going to be 7. Then it's going to be 5. Then it's going to be 3. Then it's going to be 1. All right, for the next one, write a rule for the nth term of the arithmetic sequence. So in this case right here, we're not given the common difference. We're given the 5th and the 10th term. So we can say we got a sub 1 dot 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 to a sub 5 dot 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 to a sub 10. We know that this is 41, and we know that this is 96. And so from this point right here, how are we going to find the common difference, which we need? And how are we going to find the first term, which we also need? So first of all, I'm going to look for the common difference. So I know that from the 10th term to the 5th term, the total difference is 96 minus 41. So if I do 96 minus 41, I get that the difference between here is 55. And how many terms are between them? So if I go from 5 to 6 to 7 to 8 to 9 to 10, that's 5 terms right there. And so that would mean that each term would have to be increasing by 11. So there you go, you have your common difference. So if you do 55 divided by 5, you're going to get that the common difference is 11. So that makes sense. Yeah, so 41 plus 55 is going to give you this right here. Divide that by the number of terms, which is 5. Okay, and then if you go backwards, so again, the common difference, this is kind of like working backwards like we did here and this one right here. So if I'm going back right here, so A1 to A5, that's A1 to A2 to 3 to 4, A1, 2, 3, 4, 5. Yeah, that's 4 terms right there. So from A1 to A5, that's 4 terms for 11 times. So that's a difference of 44. So if I do 41 minus 44, I'm going to get that the first term is negative 3. So to write my rule, a sub n is going to be equal to 11 times by n minus 1 minus 3, just to kind of verify. Let's say I want to find the 10th term, so I'm going to plug in 10 here. So if I do 11 times by 10 minus 1, that's 11 times by 9, which is 99, and I subtract 3, and I get 96, so it works out perfectly. If you want to verify one more time, you can plug in 5 for n and verify that that's the 41st term. All right, and you'll do the same thing for number 9. So for 9, we'll have a1 dot 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 dot. We'll have a6, which is negative 8. And then we'll have the 15th term, which is going to be negative 62. So how much is the total distance between here? So if you do negative 62 subtract negative 8, you're gonna get that doesn't no, that's right. You're going to get negative 54. So to go from here to here, that's negative 54. Negative 8, yeah, negative 8 to 62. Or you can even just do, like, think about it as 62 minus 8. If you think about it in terms of absolute value, you're going to get 54. But because you are decreasing from negative 8 to negative 62, it's negative 54. And how many terms are between here? So from 6 to 7 to 8 to 9 to 10, 11, 12, 13, 14, 15. that's going to be 9 terms. And so I'm going to take negative 54 divided by 9. So 54 divided by 9. That's going to be equal to 6. So negative 6. That's going to be equal to negative 6 as the common difference. All right, and then I want to go back from 6 to 1. So that's going to be a total of 6 terms. 6 terms at a common difference of negative 6. So negative, that's going to be 36, negative 36, right? Yep. So whatever I had here, I subtracted 36 to get here. So if I do negative 8 plus 36, I'm going to get 28. So this first term right here is 28. So a sub n is going to be equal to negative 6 times by n minus 1 plus 28. Let's verify this. Let's say I want to find the 15th term. So plug in 15. So we're going to do negative 6 times by 15 minus 1. So negative 6 times by 14 and add 28. Oh my gosh, I'm so bad at this. I'm not getting the right answer. I'm getting 56. I should be getting 62. Should be getting 62. What am I doing wrong again? Let's go back. I'm pretty sure this is right here. So if I do negative 8, and then if I subtract 54, I get 62. Do I have the number of terms right? From 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 9 times. So my total, okay, 96. So, and then, oh, I did 6 times 6, not 30. Okay, so that's where it's wrong. That's not 28. So there are 5 terms here. I did negative 6 times by 6. So negative 6 times by 5. That's negative 30, not negative 36. So if I do negative 8 plus 30, I get 22. That's my first term. So 22 is my first term. 22, let's verify. So again, if I'm looking for the 15th term, plug in 15. So I've got negative 6. And then times by 15, 14 times by 14. Times by 14 plus 22, I got negative 62. Okay, so that works out. For these ones right here, find the sum. So find the sum of this series. So there's there's a formula that we use whenever we're trying to find the series of an arithmetic sequence. It's so we use S sub n. S sub n is going to be equal to let's see, it's n times by a sub 1 plus a sub n all divided by 2. I think. Is that right? Let me double check. I think it's right though. Yes, it is. All right, and so let's go ahead and, so this is the sequence right here, and we're adding up the first 20 terms. So it would kind of be equivalent to if we were to add up all the terms in this one right here, what would the total value, what would the value be? That's essentially the idea of what we're doing here. But this is a shortcut. Very nice formula. So n refers to the number of terms. So that's going to be 20. So I'm going to say S sub 20 is going to be equal to 20 times by a sub 1 a sub 1 is going to be the first term, and I can find the first term. So since this is the rule for the sequence, I can just plug in 1 to find the first term. So 2 minus 3, which is going to be negative 1, and then plus a sub n is referring to the 20th term. So I can find the 20th term by plugging in 20. So that's going to be 40 minus 3, so that's going to be 37, all over 2. So then in that case, you got your calculator. That's going to be 360, I think, right? That's going to be 10 times by, yeah, that should be equal to 360. For this one right here, so we have 26 terms, so we'll say S sub 26 is going to be equal to 26 times by the first term. So if I plug in 1, I'm going to get 4 plus 7. 4 plus 7 is going to be 11. And then plus to find the last term, the 26th term, so 4 times by 26, and then add 7. That's going to be 111. All over 2. So 26 times by that right there. Let's see. 11 plus 111. And then you're going to divide that by 2. Let me do that right there. Divide by 2. And then times by 26. Nope, that's not what I wanted to do. Alright, I've got 1586. That should be right. Let me just verify one more time. 122. 61 times 26. Yeah, that's fine. Alright, for this one, we'll say S sub 33 is going to be equal to 33 times by the first term is going to be, I'm plugging in 1 here, 6 minus 2, that's going to be 4. And the next one's going to be minus, because I'm pretty sure it's going to be negative. So if I do 6 minus 2 times by 33, I get negative 60. So 4 minus 60. Okay, that's going to be equal to negative 56. And then we're going to divide that by 2. And then we're going to multiply that by 33. So I have negative 924. For the next one, we're going to do S sub 31, which will be equal to 31. And then we're going to plug in 1. So negative 1 minus 4, that's negative 7. Then we're going to plug in 31. So we're going to have negative 3. And then we're going to subtract 4 times by 31. And I have minus 127. All right. So we're going to have negative 7 minus 127. We're going to divide that by 2. And then we're going to multiply that by 31. And I have that this is equal to negative 2077. Okay. Recursive arithmetic sequences. So write the first 6 terms of the sequence. So here's the recursive rule. What we've been using all along has been the explicit rule. But the recursive rule just says, here's the term that comes before the nth term. And then if I add 3, this is the common difference. So this is the common difference right here. And it tells us that the first term is 1. So if the first term is 1 and it has a common difference of 3, the next term is going to be 4, then 7, then 10, then 13, then 16. And there you go. You have the first 6 terms. Over here, we have, again, this is the common difference right here. And it's negative 5, so we have the first term to be 1. And then we're going to subtract 5, so that's going to be negative 4. We're going to subtract 5, which is going to be negative 9. We're going to subtract 4 again, which is going to be negative 14. We're going to subtract 5, which is going to be negative 14. We're going to subtract 5, that's going to be negative 19. We're going to subtract 5, that's going to be negative 24. I think that's all the terms that we have right there. For this one, it says write a recursive rule for the sequence. So all I need, I'm going to write that a sub 1 is equal to 21. And then I'm going to write a sub n is equal to a sub n minus 1. And then I'm going to add, or plus or minus the common difference. So the common difference here is minus 7, so a sub n minus 7. So that's how you'd write a recursive rule for that sequence. Here, I'll say a sub 1 is equal to 54, and I'll say a sub n is equal to a sub n minus 1. The common difference here, so from 4 to 3, is that 11? Yeah, so minus 11. And there's the recursive rule there. And this one right here, write a recursive rule. Oh my gosh, we're still writing recursive rules. Oh, so this right here is an explicit rule, but it wants us to write a recursive rule. So I can tell that the common difference here is equal to 4. The first term though, so a sub 1 would be equal to 3 plus 4 times by 1, which is going to be equal to 7. So I'm going to say a sub 1 is equal to 7, and I'll say a sub n is equal to a sub n minus 1 plus 4. There's my recursive rule. And you can see here that the common difference is negative 10. A sub 1 is going to be equal to 12 minus 10 times by 1, which is going to be equal to 2. So a sub 1 is equal to 2, and a sub n is going to be equal to a sub n minus 1 minus 10. And then for this one right here, for these two, write the explicit rule. Here's the recursive rule. So you can see we have a sub 1 is equal to 3, and then this is equal to the common difference. So the explicit rule is a sub n is equal to negative 6 times by n minus 1 plus 3. And then here we have the first term, we have the common difference. So we'll say a sub n is equal to 7 times by n minus 1 plus 16. And there we have all of 7.2.